Hi, I'm Yuvraj Newell, and I'm going to be talking through my planning for directed numbers. I'm going to start off with part one, which is the big idea, then talk about part two, which are the prerequisites, the things that they need to know before we can start exploring this topic. Part three, the key models and representations I plan to use to help students learn, and then finish with part four about why this is important, where this can go with future learning. So what do students need to do? Students need to be able to perform the four operations on negative number. In this video, I'm only going to focus on two of those operations, which will be addition and subtraction. So when I start thinking about this topic, I try and think about the misconceptions. And these are the things I want to avoid by carefully choosing my representations, by focusing on my language used in class, and breaking down this topic into smaller steps. And I'm fairly positive, pardon the pun, that we can unpick these if they do come up. So hopefully the sequence I will talk through should mean that if they do come up, I have a way of addressing these misconceptions. But some of the key ones are that a minus minus is plus, or that two negatives make a positive. The other misconception some students will bring in is that -7 is less than 3. They may not see the symbol in front of the 7 and may just focus on the absolute size of the number. The other picky part of this topic is that the symbol and the operation look identical. And this is a big problem for some students. The other baggage they may be bringing to these lessons is that addition has always made things bigger and subtraction has always made things smaller. So we're looking to look out for these misconceptions and address them. So this is the experience of directed or negative numbers students should have had coming into secondary school. Most of the mathematics involves going through zero, counting backwards, and most of the arithmetic is highly contextualized. The guidance in the Key Stage 2 national curriculum suggests that primary teachers should use a number line. So they will not have had much experience of using double-sided counters, which is something I plan to use in my planning of this topic, and I will mention more about why later in this video. So these are the types of tasks I'm going to use prior to starting any teaching of directed numbers. What I'm trying to do is ascertain how familiar students are with the idea of negative numbers and the students' general feel for the arithmetic. I would keep in mind any issues thrown up from these types of activities and use that information to plan for future lessons also. As I plan to use double-sided counters instead of a number line, I'm not overly concerned if students haven't quite grasped the idea of addition and subtraction using that number line. The key thing I want to see is if they recognize that -7 is less than +3. And sometimes students fixate on the number rather than the sign, and 7 has always been bigger than 3. So these are things we need to kind of look out for, and that will help them when they make sense of some of the answers they should get. Some of the Key Stage 2 type questions are shown here. And these are quite nice just to check that students have understood or are capable, have the prerequisites in place to kind of move forward with the new learning. So this is what the national curriculum states that students need to know about directed number. The first part is identical to what they should have covered in Key Stage 2, but the second bullet point is the new learning part. This is where I'm going to focus much of my planning, and in this video, just on addition and subtraction. So in terms of teaching this topic, I feel that language is absolutely crucial. The language we use can really help students distinguish between the operator and the symbol. I mean, they look identical in this topic, but sometimes the subtraction sign is denoting an operation, and sometimes it's used to denote a negative number. So I would read the calculation on this slide as +5, add -2, not 5 plus -2. And even now I have to kind of catch myself in the classroom. And I also insist that students read out the question in my classroom correctly before giving their answer. So for example, a student will say, when answering this question, +5 plus -2 equals +3. And the point here is to avoid plus minus is minus syndrome, which can be reasoning kryptonite in some cases. Now, representations are key in this topic for me. You can use algebra tiles as used in the NCETM using mathematical representations at Key Stage 3 algebra tiles document. Or you could use double-sided counters as shown in the NCETM operating on number document. The counters in my school are red and yellow, not red and blue as shown in the guidance, but that's really not something you need to worry about. Both of these documents are well worth reviewing as part of your planning, and they can be both found on the NCTM website or Googling NCETM secondary PD materials. And they're quite useful to use in your department settings as well to get that conversation going about how we can approach this subject. So I mentioned before the number line versus double-sided counters. When I first started teaching, I always used the number line when teaching directed numbers. And I would show examples and illustrate on the board about which direction I should move in and in which scenario. For example, if we were adding a negative number, we would move to the left. And if we were subtracting a negative number, we would move to the right. Now, upon reflection, I would say my approach was not overly successful, as students would often get in a muddle about which direction they should be traveling in. Students were also rule takers in this scenario. They were being given rules to follow by the teacher without any appreciation of what was happening mathematically. Not only were they rule takers, but they were also having limited success, so they were taking those rules incorrectly at times. And it was only a few years back that I was introduced to double-sided counters, and they've been a real revelation for me for how I've taught directed numbers. I feel that they allow the students to see the maths more visibly, and they're able to create their own schema or their own rules. They've kind of moved from this position from being rule takers to rule makers. And using the counters also allows for students to behave more mathematically because they can start making predictions and inferences using those counters and then testing those predictions and inferences. The model is also really useful for simplifying expressions. So investing time in getting students to understand this model can help with future topics too. And the counters are more in line to that concrete pictorial abstract approach, which is shown to be quite successful for students. I also moved in this direction after listening to a talk by Professor Jeremy Hodgson and Dr. Colin Foster about understanding and addressing low attainment in lower secondary mathematics, which suggested that lower attaining students really dislike the number line. One of the key ideas with the double-sided counters is the zero pair. The zero pair is a very powerful idea when adding and subtracting with directed numbers. Understanding this topic is absolutely crucial for the calculations we will explore when we use a combination of negative and positive numbers. So I would spend a bit of time showing them different zero pairs so that they're able to recognize them. And I tend to arrange the counters as above, as I don't want any mistakes from miscounting. That's not the idea here. The idea here is to recognize a zero pair. And it's also a nice way to model a technique for students to follow by arranging the counters in a way so it's easier to spot those zero pairs without having to physically count them. And at some point, I may ask students to make their own zero pair and have their partner check it, or I might ask them to draw a pair of zero pairs on their mini whiteboard to hold up for me to check. Now, once I'm confident that students are able to spot zero pairs, I would look to represent the same number using different amounts of colored counters. This again reinforces the idea of zero pairs, but also develops their understanding of using the counters. What I want students to notice is that we can represent the number 1 in a variety of different ways. And I would ask questions such as, what is the same about the representations of the number 1? Now, hopefully they will notice there is always one more positive counter than negative counters. I'd ask them, what is different about the representations of the number 1? And this is mainly to hammer home the point that we can use an infinite amount of counters to represent the number 1. As before, I may ask students to create the number 1 with their own counters and have a partner check it, or I might ask them to draw me a picture for a different representation, again to check to see if students have understood this idea. So now we're comfortable with the idea of zero pairs and different representations of the same number. So where do I go from here? Well, time to take some baby steps and to see if we can see the effect of adding and subtracting counters to our model. And I would now zero in on the odd one out. The idea of the questions here is to elicit some more information about what students know and their intuitive feel for the model so far, and to flush out any unanticipated misconceptions before I progress with this topic. The last question will also allow me to see how much I will need to model subtracting negative numbers if the model does not have sufficient negative counters to subtract from. I would ask students to carry out the addition and subtractions using their own counters, so they get used to the idea of using the counters and they can start visualizing or seeing the maths and how it's occurring. This is also a great way to see which students may be ready for a more difficult challenge and to see who can do these kind of calculations without using the counters. So at this point, I'm thinking that students need to try some examples of their own. And I've chosen to focus on addition only. Now, why have I done that? Mainly because I want to break the two operations down into small steps. And addition is easier than subtraction as there are only adding counters to the representation or the model that we're using. I make sure I choose questions that they can model with the amount of counters I've distributed to each child or to each pair. The only thing changing is whether the number is negative or positive in each question. The reason for this is I think that it's a nice opportunity to also revisit the ideas of commutativity. The natural extension here being to group the questions with the same answers and then asking students if they can explain why they have the same answer. And then I could ask, would this be true for different amounts? I can introduce some generalization here. For example, is positive A plus negative B the same as negative B plus positive A? Right. Time for some practice. I'm conscious not to overload students and focus on two negatives only in the first set of questions. This is to allow students to build confidence and experience success early on, which can lead to better motivation. We would then look at one negative number and one positive number, but the operation would be limited to addition only. Now, Chris McGrain has shared this on Twitter, and this is a lovely way to structure the questions you give students. For each question, I'm going to ask the students to draw a diagram on their sheet, and this allows me to see if they've represented the calculation properly. I'm going to ask for the number sentence in words, and then I'm asking them to rewrite the questions as well, so they can see what a negative number when it's sometimes used with a bracket in front of it and sometimes without a bracket at all. Now, you could use a visualizer here to help model with students, or you could use MathBoss to display any questions you want to draw your class's attention to. But this really does hammer home the key parts of language I'm planning to use. Now, whenever I plan these a lesson, I don't think, or a topic, I don't think of a number of lessons I want to spend on a particular aspect. It will always vary from class to class, but I don't want to move pupils onto something different. My intention is to try and keep the class together. So I'm looking for depth rather than acceleration. And as pupils are always going to work at their own pace, and some will grasp ideas quicker than others, so it's always valuable to think about extension tasks. Going back to the generalizations, you could ask students to give an example of when the answer would be positive in these cases, or when it would be negative. And you can also ask them to discuss if they're always positive, sometimes positive, or never positive. You could also ask for an example of the calculations when A plus negative B equals negative A plus positive B equals negative A plus negative B. You could also give very large sums and ask them to state whether they think the answer is positive or negative. And this is quite nice as it allows you to see how students are thinking about whether their answers are making sense or not, a kind of inbuilt checking mechanism. You could also throw decimals and fractions in there. So hopefully my class is comfortable with adding directed numbers, so we can begin looking at subtracting directed numbers. Before we do any examples, I would recap the idea of a zero pair and the idea of representing a number using different amounts of counters or algebra tiles. Now, we haven't used these representations in adding directed numbers, but I did introduce the idea very early on. Now, why did I do this? Well, I wanted the students to hear the explanation of it at least twice before we start using those ideas. Again, I start with some examples so they can see the maths using the counters. And I pick examples where the number of negative counters at the start is larger than the number of counters we need to subtract or take away. So this first number is more negative than the second number. This way, the students are physically able to subtract or remove the counters from the model. So we have, what I would do now is model this with my counters, and I start with negative 2, negative 4, and I can subtract negative 2 counters and they can see the answer. I'd then go through another example and I start the model off with -3 counters, and then they can subtract -2. And then I can do this with another example where I have -8 counters, and they can subtract -3 counters. And this will hopefully allow the students to see the mathematics in front of them. I would then ask students to work through this sequence of question. Question F, they should be able to do via pattern spotting, but asking them to model it using counters will be the challenge. And this is the segue into using a different number of counters to represent a number. And I may throw this open to the class to see whether they have any ideas, or I may choose to explain it once they've encountered it, depending on how that class is getting on. And this is where all the ideas really come together. The idea of the zero pairs, there are different representations of the counters, and I would state how we can use a zero pair so we are able to physically take away 8 negative counters, leaving us with only 2 positive counters. I would do several examples of this, firstly with me explaining, then gradually fading by asking students, okay, what should I do next? So they are comfortable and familiar with this idea. Again, every example I show, the minuend will be negative and the subtrahend will also be negative. I'm not throwing in any positives in yet, as I'm trying to break this topic down into smaller steps. After some further practice, another great discussion is to take it back to the generalizations. Again, when is -a subtract -b positive? When is it negative? Can you give any example, etc., etc.? And the nice thing about this topic is most of the extension tasks you can reuse. It would be at this point where I would now introduce a positive minuend. Again, we are using the idea of zero pairs to represent numbers to allow us to physically take away 3 negative counters. So modeling this is always a great idea, and getting pupils to do the same with their counters at the same time. You can ask students to whether they would ever get a negative answer to A subtract -b, and you can ask for questions like that just to probe their understanding. Once I feel students are happy with the addition and subtraction with integers, I may throw some decimals and fractions in there, but this will depend on your scheme of work and whether students have encountered those ideas beforehand. Now, this is a nice summary activity to get students to create their own questions and to work on their fluency. And one of the nice extension tasks is to see which answers are the same and which answers are not the same. So for example, when can I swap the two around, or when I can't swap the two around, and why they are the same. So there's nice elements of investigation in this topic. And here students are generating their own examples and able to explore further and work on their fluency. So why is it important? Well, I'm investing a lot of time in this model because the idea of a zero pair can really help us with future learning with simplifying expressions. So if we take the first question here, 2x plus 3y, subtract 5x plus y, by rearranging and collecting the like terms, I can model this so that students are able to simplify in the same way they use negative numbers.